Yeah, seashores. Okay. So, the seashore, tides have a huge influence on life here. The intertidal zone is the portion of the shoreline that's covered with water at high tide and exposed to the air at low tide. So only certain organisms can live there, because if you have like fish and they're not in a pool and the tide goes out and they're stuck in the mud, they're going to die. So organisms in the intertidal zone are adapted specifically to be able to be dry for hours at a time. And in a lot of the shorelines, that involves getting very hot. If you're a clam sitting on a rock and the water goes out and the sun's beating down on it, it can get really hot or cold depending on the area. This is the area with the most extreme tides in the world. And you can see just from the boat, it's up here, and then at low tide, it's sitting on the ground. This is the Bay of Fundy. And so everything in this whole area, if there's any organisms there that aren't attached, that if they're not loose and can swim out with the tide, they have to be adapted to being dry for hours at a time. So the tides are controlled by basically they're caused by the gravitation of the sun and the moon. The lunar tides are stronger, even though the sun's bigger, because the moon is way closer. And the timing is very complicated and has to do with the shape of the shoreline and the shape of the ocean basin in front of it. It gets very complicated. I honestly don't understand how it all works, but we can talk about where it is and everything. Depending on the shape of the coastlines, how it's connected to the ocean, and other factors depends on the size of the tides. The Gulf of Mexico, where I did all of my work, the tides are very small, like less than a foot. One of the jobs I had, we were supposed to go out and sample the marsh, and we were supposed to be there at high tide to sample it. Another time, we were going out to transplant seagrass, and we needed to be there at low tide. The problem is, in the Gulf of Mexico, the tides are so small, the wind can override it. So if you're supposed to be there at high tide and you get a north wind, the north wind will push the water out of the bay, and the tide will be low, even though by the clock it's supposed to be high. Places where the tides are higher, the wind is not going to be able to change that. The wind can change it a couple of inches, but if you're changing it by 12 feet, then the wind's not going to make a difference. Gulf of Mexico average tide range is about 1.5 feet. Now, if you're on the beach and there's a very gradual slope, that can move the water quite a bit. The water can go out 100 yards or so, but it's not be going up and down very much. You can't get stuck at low tide and drown from the tide like you can in other places. And in Britain, if you're hiking along the cliff and the shore, and you don't pay attention to the tide, when the tide comes in, it'll drown you. So this shows the different sizes of the tides around the world. And you can see this whole area, the Gulf of Mexico and the Caribbean, are very low tides. And yet, just on the other side of the Panama Canal, you have super high tides from here. The highest tides in the world are up here in the Bay of Fundy. And you can see Britain has really high tides, and the coastline of Australia. But again, you look at the right here, they've got really high tides on this side of the island and really low tides on this side. So it's complicated. You can see for the most part, the higher tides are on the west coast, and you have lower tides on the east coast. But not always, there's exceptions. Okay, so the Bay of Fundy is the largest tide range on Earth. The tides rise and fall 53 feet twice a day. That's a huge amount of water, and if you live in that area, you have to pay very close attention to that. Okay, so let's see if I have this set up. There it is. Okay, so the Gulf of Mexico has what kind of tides? Okay, so the Gulf of Mexico has very low tides, low tidal changes. Not very low tides, that doesn't mean the same thing, but the change is very little. Okay, so let me fix this. Let me share. Okay, so watch this. Maybe. There it goes. They actually have to have special pulley systems to tie up their boats because otherwise the boat would end up just hanging from the top of the dock. There's a difference between high and low tide in a couple of spots. You see there's miles of mud flats that aren't there at high tide. This is pretty cool. This shows you from sunrise to sunset. 100 billion tons of water twice a day. A lot of the rocks have this distinctive shape because there's erosion here, but not up here. And see all these people wandering around. Now it starts to come in. Now you see people boating. Stop quick right here. Hold on a second. The video is not working over there. So then it goes back down the same daytime, the same day. You have people walking around it again. All right, so the timing. There we go. Okay. Some areas, and again, this to show you how complicated it is, some areas have semi-diurnal tides, 2 high tides and 2 low tides each day. The tide changes every 6 hours. Others have diurnal tides, 1 high tide and 1 low tide. The tide changes every 12 hours. Gulf of Mexico, where I was, we had the diurnal tides. But the Bay of Fundy, where you have 50-foot tides, it changes twice a day. Here you can see like the Gulf of Mexico has diurnal tides. This coast has semi-diurnal. Pretty much the whole ocean basin is semi-diurnal tides, except here where it's mixed. So it's very complicated. Okay, so the intertidal zone can be sandy or rocky. Small fish, clams, crabs, and other mussels are trapped in pools during low tide unless they get flushed out. Tidal pools, we didn't have a lot of tidal pools in where I grew up because there's no rocks. So you just had sand. There were a few against some of against the seawall, there are a few places where you get tidal pools. But like on the West Coast, there's all kinds of interesting things in the tidal pools at low tide, starfish, sea anemones. Okay, so let's talk about the ocean. Once you get away from the shoreline, you divide the ocean into two main life zones. The photic zone, photo means light, just like photograph. Photic zone, you have sunlight. The aphotic zone, no sunlight. And the photic zone, depending on where you are, can go down to about 200 meters. In Galveston, I keep talking about Galveston, but that's where I went to college and I lived in that area. You could stick your head in underwater a foot and it would be pitch black because there's so much sand in the water. But in clear water, it can get down to 200 meters. There's still enough light for photosynthesis. Of course, all of this, there's not enough light for photosynthesis. So the photic zone can be divided into the euphotic and the dysphotic zone. You have sunlight penetrating into the euphotic zone. The dysphotic zone, there's a little bit of light, but not enough for photosynthesis. They call it the twilight zone. Plant life and animal life is abundant. The aphotic zone, below 200 meters, you do not get sunlight. There are no plants at all, of course, because plants need light. The animal life is highly specialized. There's things like the triggerfish. The one in Finding Nemo was similar to this. Just to tell you, and we talked about this when when the deep sea presentation was talked about. But they usually have huge stomachs, so when they do find food, they can eat as much of it as they can. So you've got fish like this, they can eat something almost bigger than they are because their stomach stretches. And a lot of them are bioluminescent. Again, with the anglerfish, the males are parasitic on the females, and they'll bite onto her at a young age, and their circulatory system will fuse, their body will atrophy except for the gonads, and anytime she wants to lay eggs, she doesn't have to find a male because the male's attached to her. Okay, so what do we have in the photic zone? Okay, so remember the photic zone has light. The dysphotic zone is a little bit, but not enough for photosynthesis. And aphotic means there's no light. A means without. Okay, so many of the denizens of the deep ocean have a special adaptation known as bioluminescence. Some of them use it to attract prey. Believe it or not, there's one that I guess would be more in the dysphotic zone. It uses bioluminescence as camouflage. You think, how does bioluminescence hide them? But the bioluminescence is the same color as the little tiny bit of light coming from the sky. And so their belly, they make the light shine with the same color as the light coming from above, and they disappear. It's crazy. Okay, we'll go over this real quick. I think we'll be able to finish. Okay, so coral reefs. They're among the most diverse and productive environments on Earth, located in warm, shallow waters of tropical coastal oceans. So the two big hotspot biomes are the coral reefs in the ocean and the tropical rainforest on land. Both of those have a huge percentage of the biodiversity is so high, a huge percentage of the animals and plants live in those areas. Coral reefs are named for the coral animals whose hard calcium carbonate skeletons make up the primary structure. I don't think we're going to talk about this, but in the coral reef adventure you watched, they talked about atolls. So if you have a volcano, that has a circular edge and the crater in the middle. Eventually the volcano is going to erode away, but the coral builds up faster than the ground erodes, and so you end up with a ring of coral. The coral and the algae, it should have an E in it, live symbiotically, using each other to survive. The reason the coral bleaching happens is because the water gets too hot and the algae are ejected, and a lot of the corals that have these symbiotic algae, the zooxanthellae, cannot survive without them. They're usually within 40 meters of the surface. There are some that are a little deeper than that. There's one in the Gulf of Mexico that's deeper. And you've seen pictures of coral reefs. You know what I should do next time? I did it for my zoology class, but I haven't done it for you. My wife and I set up a coral reef tank. And so we have a tank with some live corals in it. There's several of them that can be bred in captivity now, and you can buy them for your tank. So I will show you the coral reef aquarium next week. Here are the polyps of the corals. We talk about these a lot in zoology. And talking about the different things that live here, this is a hard coral, this is a sponge, and there's some soft corals here. This incredible amount of biodiversity. Okay, so that's all for today. We'll move on to cycles next week.